dotted line represents input is 1. From B1 to D2, input is again 1. From D2 to D3, again we are following this dotted line. So the input is again 1. Okay. So for this segment, the first segment, the input was 1. Second segment, the input was 1. For the third segment, the input was 1. Okay. So I have written in the circular form. This is written in the circle that 1, 1, 1. So this was the input. And we have determined. So first of all, we have to determine that whether we have received the error signal, error bit sequence or not. Okay. How to determine that? If we receive any path with 0 matrix, any path with 0 matrix, that means this is a 0 value, then we will come to the conclusion that we have received a error-free code. Okay. Then we have to determine, then you have to follow that path which possesses the 0 matrix. Okay. So suppose I'm taking an example. Okay, just let me use it. Suppose we have received 1 1 1 1 0 1 and 0 0. Okay. So like similar like previous way, we have already draw this port release diagram from A0, A1, A2, A3. So we have considered 3 segments like before, like 1 1 0 1 and 0 0. So this segment is for 0 0, this is 0 1, and this is 1 1. So if you follow, you have to just write all the outputs, and you have to calculate all the Hamming distances like before. And I'm just showing you that if I'm following this path from A0 to B1, this is 1 1. Okay, we have received, we have the output as 1 1 when A0 is the present state and the next state is B1. Okay, so this output will be same. The output will be same. Okay. Now, when I'm considering present state as B1 and the next state is C2, then the output is 0 1. So here the Hamming distance in the first segment, this is 1 1. So this is 1 1. This is 0 1, and this is 0 0. Okay. So this, for this path, I'm following this path. Okay. For this path, I'm going from A0 to B1. So this is 1 1 output. Calculating the Hamming distance between the received code and the output, I'm getting Hamming distance as 0. Again, for B1 to C2, this is the output 0 1, and the received code is given 0 1. So this is also Hamming distance as 0. And again, this is 0 0, and I'm coming from C2 to B3, and this is the output 0 0. So the Hamming distance again 0. So if we add this, if we calculate the path matrix, what will be the value? This will be 0. So the path matrix for A0, B1, C2, B3, the path matrix is 0. So now we will say that we are receiving correct code. Okay, there is no error. Now what was the input? What was the input? We have already decided that we have received the correct code. Now we have to compute the what was the input. So this is the procedure. That means this dotted line is for 1. So this is 1. As you can see, this is 1. From B1 to C2, I'm following this path, B1 to C2. And this path is bold line. So this is used for the input 0. So that's why we can conclude that the input was 0. And from C2 to B3, I'm using dotted line. So dotted line represents input 1. So this is 1. So we can say that the input was 1 0 1. Okay. So for the path A0 B1 C2 B3, that means A0 B1 C2 B3, the path matrix is 0, and you have to compute all the possible path and path matrices, and then you have to say that, so we have received an error-free code and the input was 101, and this is 101, and we have computed from this path. Okay, so this is the technique, this is the whole technique of viterbi algorithm. From the previous example, considering this path as 0, if we assume that this path matrix is 0, then input will be what? This path following the dotted line, so this is input 1. This path is also following the dotted line, so input is 1. D2 to D3 following the dotted line, so input is 1. So input was 1, 1, 1, 1. Okay, so this input corresponds to this code, that means received code. This is an error code. So first of all, we have to follow the code trellis diagram. We have to write it like this: present state, next state, then possible outputs, all the outputs you will compute from the table. Okay, then you'll be given a received code 1101 and 11, like this. Any kind of example may be there. So this is the received code. You have to just come to the conclusion that whether this code is error free or not. Then this is the next step, that you have to draw the code trellis diagram. Then you have to write all the possible outputs and corresponding Hamming distances with respect to the received code, like this 11. This segment is for 01 and this is for 10. Okay, so for this segment, all the Hamming distance will be computed. For this segment, all the Hamming distance will be computed with respect to 10. For this segment, all the Hamming distance will be computed with respect to 01. Okay, so from this segment, whatever the output we are getting, the Hamming distance between the output and the received code word, okay, will be computed with respect to this 01. This also, from this also, we have considered 11, the first sequence, the first bit sequence of the received code, and we have got the outputs, possible outputs, and we have computed the corresponding Hamming distance. So after writing all the possible Hamming distances, you will get all the Hamming distances. Then you have to make the path, all possible paths from A0 to A3, A0 to B3, A0 to C3, A0 to D3, all the possible paths and corresponding path matrices. Okay, then you have to determine that whether you are getting any kind of path which possesses the 0 path matrix value. If you get any kind of zero value, then you will come to the conclusion that you are getting error free code, and then you have to calculate what was the output, what was the input. Okay, what was the input corresponding to that path. So that path is basically the error free path. Okay, so that is the step-by-step procedure, and you will get the input as I've seen. I've just shown that this is the example. This is 0, 0. So in this path, this is all the Hamming distance as 0. So adding this Hamming distances, you will get the path matrices, and this path matrix will be 0. Then you can say that we have received the error-free code, and that will be the corresponding input. Okay. So this is all about viterbi algorithm. So you may be asked in your examination that what is viterbi algorithm, or discuss viterbi algorithm taking any example. So you can take this example. And in your examination, you have to just show the table we have made in the previous lecture. So depending on that way, I've just told you all the diagrams like state diagram, code release diagram, code tree diagram. So uh, when any question will be asked like describe code tree diagram, describe code release diagram, describe viterbi algorithm, so you have to uh, draw that table, you have to draw that encoder also. Then you have to compute this thing. Okay. So if you're facing any doubts or if you're facing any problem, so you can contact me. I hope you will understand, because this is very difficult to make you understand by this procedure, by this handwritten note. This is totally depends on board work, but this is not possible. I've tried. Okay. So if you're facing any problem, so please contact me. Don't hesitate. So thank you.